See, you just thought that the previous problems were difficult. Look at this guy. Now, before we dive into this, please understand that we're just working with numbers. There won't be anything here that has any bearing on how big of a number 23 or 37 or 12, doesn't matter how big they are. It's all about the process. The big thing we need to understand is that the x's that we are trying to, or the x we're trying to solve for, is in the power. And almost any time that you have the variable in the power, we need to apply logs so that we can use the proper logarithms to bring them out in front. So, first things first is we apply the natural log to both sides. Doing so, that brings the power, so in this case 5x minus 12, brings it out front, times the natural log of 23. The right side, similar thing happens. That's going to be 6x plus 29 times the natural log of 37. Okay. Now I know there are more pieces here than we had in the previous problems. The concept is still going to be the same. Natural log of 23, natural log of 37, those guys are just numbers. That's all they are. They're not pretty, they're not the nice guys you want to think of, but they are just numbers. I can go to the calculator and type in the natural log of 23, and you see it's just a number. Now I don't want to have to write that number all the time, so writing natural log of 23, which is exact, is much more portable than writing that horrible and nasty decimal, which is not exact, because they have to round it at some point, because the decimal representation never repeats and it never ends. Okay, so because these guys are just numbers, we're going to distribute. So that means we're going to have 5x times the natural log of 23 minus 12 times the natural log of 23. On the right side, we distribute the natural log of 37, so it's 6x times the natural log of 37 plus 29 times the natural log of 37. All right, now focus. There's x and there's x. In order for me to solve for x, especially since I don't have x squared, I don't have x in a radical, I don't have even weird x, I just have plain x to the first power. When that's the case, you want to get all of those terms that have x on one side and those that don't have the variable that go on the other side. Now, you might be kind of frustrated or disappointed that these guys right here aren't really the same kind of terms because you've got natural log of 23 and natural log of 37. That's okay. So I'm going to move this piece over here to the left as a negative. I'm going to take this guy right here and move him to the right. So I'm going to keep my 5x, natural log of 23, and I'm subtracting over this term, so minus 6x, natural log of 37. On the right side, I already had 29 natural log of 37, and when I move this piece over, it becomes plus 12 times the natural log of 23. All right. So again, eye on the prize, there's my x. So what I need to do is I need to factor that x out of both of these terms because I can't combine them. So if I factor out the x, I'll be left with 5 times the natural log of 23 minus 6 times the natural log of 37. And then at this point, I'm just copying down what I have here on the right side. Make sure that as you go from line to line, you don't miss a number, you don't write the wrong number. I'll be honest, I'm guilty of doing that. Sometimes I go too fast, make careless mistakes, it's very frustrating. So here is the only x that we have. And this is x times a bunch of stuff. Now, all of this is just a number. I could go to the calculator and just type that in, and it's going to give me a decimal. That means this is really the coefficient of x. So I'm going to divide both sides by this number. Again, I don't really want to know what the decimal is because it's going to be messy, and it's not going to be exact. So for a lot of the stuff that we do in math, we want to be exact, if at all possible. And it is possible for us to be exact here. But I want you to see what happened to those numbers, the 29, 23, 37. I didn't actually do anything with them. I moved them around, but I didn't have to do a big product with them. I'm not getting really huge numbers. I'm just applying logarithms and getting x by itself. So this is an exact value. So let's now see what the approximation is. All right, so we have, again, pay very close attention to this. Big parentheses for the numerator and for the denominator. If you don't, you're not going to get the right answer. So I'm starting with big parentheses. 29, natural log of 37. I type natural log, so open parentheses. I need to close that off so it's just the 37 in there. Plus, now when I'm doing the plus, I'm still inside the bigger set of parentheses that I opened. This is 12, natural log of 23. Close the natural log. Now I can safely close the numerator because I'm done with it. Divided by, open up a big set of parentheses for the denominator. That's the stuff that you see right here. So 5, natural log of 23. Close that off. Don't close it off again. You've closed off the natural log, but you still need to keep the denominator open. Minus 6, natural log of 37. Let's see, what do we get here? Okay, so our answer is approximately it's a negative 23.771. Okay, now let's check this real quick. If I store this into x, now let's check to make sure that what I have on both the left side and the right side is the same value. All right, so 23 raised to the 5x minus 12. So it is telling us that it's 0. And the reason it's doing that is because it's having trouble handling how small of a number we actually have there. So 37 raised to the 6x plus 29 is probably also going to say 0. It's not actually 0. But again, the calculator is having a hard time displaying something that is going to be that small of a decimal. Because if I do 6x plus 29, I'd be raising 37 to that power. Actually, you know what? That would exceed, if I do 37 to that power, that would exceed the limitation of the graphing calculator. So here's something else that you can do. If I go to Math, and I go press up to do Solver. So equation solver, you type in one equation. That's going to be the left side here. So it's going to be 23 raised to the 5x minus 12. Second equation is 37 raised to the 6x plus 29. And click OK. It's the button right here. Oh, it actually tells me the answer. I'm really surprised that it did that. I thought we would have exceeded those boundaries. Oh well. Oh, no, I'm thinking about something different. Yeah, anyway, it's going to be a really, really, really small number, so essentially 0 whenever you plug that in. But yeah, there you go. So just make sure that you are very careful about what you do over here, applying logs on both sides, distributing like we did down here, and moving your variable terms over, factor out that common factor, and then you divide by that coefficient. And then before you know it, you'll be done.